Welcome to Applications of Linear Systems. Our goal today will be to solve systems of linear equations for real-world problems. Part of the process will involve writing equations of lines from word problems. Here are two possible types of equations we might write. We might write a linear equation in the form of y equals mx plus b. We might also write a relationship as ax plus by equals c. Please pause the video so you can record this information. Here is the overall process for reading word problems and solving it using systems. You're going to want to read the problem at least once. You're going to want to identify in step 2 the unknown. There are going to be two unknown values. One will represent as x, one will be represented as y. You can use other variables. It doesn't have to be x and y. Keep in mind that often y depends on x, so that's why you might end up writing an equation as y equals mx plus b. And so in this step, once you've identified what your x and your y is, what the question is asking about, you're going to want to define those variables. You basically just write a quick definition. X represents blah blah blah, y represents blah blah blah. In step 3, you're actually creating the two equations that will make your system. Keep in mind when you're putting together information in your problem to make your equation that usually your left side and right side of the equations will have the same types of units. So dollars on the left will mean you've got numbers of dollars on the right. If you're doing measurement or if the numbers involve some type of measurement, you can have feet on the left, feet on the right. So that's kind of a guide as to know what pieces of information in the problem will go together in the same equation. Each equation basically has a theme. So you'll kind of see me talk about that as we make our equations for the two examples we'll do in a minute. Once your equations are created, pretty much the hard part is done for you. The next part will be solving the system. Sometimes you'll be asked which method to use, or they might leave the problem open for you to decide the choice of solving method. In step 5, once you know your x and y, you're probably going to want to take a quick minute and review your answers. Take your two values and put them into the equation you hadn't really checked yet. When you're doing step 4, you're going to end up using one of the original equations to either plugging in an x or a y. So in step 5, you'll probably want to take your x and y and plug them into the other equation just to verify that those two values are the correct values. And then, of course, finally, you're going to want to report your answer with units, possibly with a nice complete sentence. Here's our first example. You don't really need to record the entire problem, probably just the key pieces of information, or just record the solution as I'm putting it together for you in this example. A rental car company charges $20 per day plus 10 cents a mile for their rental cars. Another agency charges $18 per day plus 15 cents a mile for their rental cars. How many miles will have to be driven for the cost of a rental car from the first agency to equal the cost of a rental car from the second agency? And we're going to round to the nearest tenth of a mile if necessary. After you read the problem once, it's kind of helpful to kind of maybe go back and circle and highlight some important information. So anything with numbers here, $20 per day plus 10 cents a mile, $18 per day plus 15 cents a mile, and then how many miles, right? That's something we don't know. So I'm thinking that that might be a variable. Do we know the cost, the total cost for renting a car from each company? We don't really know that either. So in my first step, I'm going to define two variables. I'm going to use m as the number of miles, that you're driving the rental car. And then I'm going to use, let's use T as the total cost for rental. Now so this is the step we just defined our variables. It's probably more appropriate to kind of use colons here instead of equals, because equals is kind of an equation type thing. So I'm not going to be too picky about those symbols, just so that you understand what's going on. In step 2, we're creating our equations. So we kind of have to think what goes together to mean something. So going back to the first sentence here, rental car company charges $20 per day plus 10 cents a mile. Mile will be my M, okay, and this whole thing is all about the cost from this car company. So I'm going to call that company A here. So this first equation I'm going to say is the cost from company A. That's not a variable, I'm just giving that company a name. So that equation is going to say the total cost is $20 plus 10 cents a mile. Means for every mile we're going to multiply 10 cents to it. And that's how much we're going to get charged from that company. $20 plus each mile times 10 cents. So similarly, for the second company, which I'm going to call company B, they didn't give the names of the company. And so that will have a total cost. It says $18 plus every mile times 15 cents. So there's our system. Before I begin the next step here, I'm going to do a little bit of editing. I forgot that step 1 is really reading the problem. So we're really now at the 4th step of the process, is solve the system. And so the question is, what's the number of miles, the same number of miles, where the two systems or the two costs are equal to each other? So they're basically asking us, when is this going to happen? This cost equals that cost. Okay, so I can use the substitution method and say if the two t's equal each other, then this amount equals that amount. Okay, I'm basically taking this here and putting it in here, or the other way around. So I'm doing a substitution method. I'm going to solve for M. So subtract 18 on this side, subtract 10 cents. Use your calculators carefully here. So after dividing out 0.05, the number of miles ends up being 40 miles. In the next step is where I'm encouraging you to check your answers. So does the 40 miles actually give the same cost to both rental cars? So in this example, I'm actually going to have to plug in the 40 miles in both equations and hope that my cost values come out equal to each other. And that will tell me that the 40 miles is actually the correct answer. And calculations will tell us that the amounts come out the same, $24 a piece. And so to finalize the problem, you just write a nice sentence with your answer, and of course the answers can vary here, but I just said one would have to drive 40 miles for the costs to equal. Here's another pretty popular type of problem. Marcos has 15 coins in nickels and quarters. The total value of coins is $2.35. How many of each type of coin does he have? So again, after you read it, go back. 15 coins in nickels and quarters. Total value is $2.35. And how many of each coin does he have? That is the unknown. How many of each coin? So that kind of hints what the unknowns are. We don't know. I'm going to go in the number of nickels. that he's got. And we don't know Q, the number of quarters that he's got. Because it's right there in the question. What is he, how many of each? So that's what we don't know. Step 3, we begin putting together information that will create two equations. I'm going to go back to the 15. 15 coins. That symbolizes how many coins that he has altogether. Altogether usually means we're adding amounts together. So I'm thinking that we're going to say the number of nickels plus the number of quarters equals the total number he's got altogether, which is 15. So this equation is representing the number of coins. Okay, so N and Q are number of coins, 15 is number of coins, so we're all balanced out. The other equation is probably something to do with $2.35, which is the total value. So now in our equations, we need to factor in what's the value of a nickel, what's the value of a quarter. When you add those values together, the total is 2.35. So we got to keep in mind with the decimal. So let's talk about the quarter. Each quarter has a value of 25 cents. And then the nickel has a value of 5 cents, which is written as 0.05. So here we have an equation all about value, which is in dollar signs. We don't need the dollar signs in the equation, but you need to be aware of this here is money, and it equals money. So our units all balance out in the equation. In the fourth step, we're solving the system. We're not specified the method to follow. Because of my first equation here, n plus q, I'm going to jump to the substitution method. So I'm going to get n by itself here and move the q over to the other side. So I'm going to have an equation that will say n equals 15 minus a q. And then I'm going to take that and put it into this spot right there for solving. So 0.05 parentheses 15 minus q plus 0.25q equals 2.35, the substitution method. So with the substitution, distribute that 0.5 here into the parentheses. Combine your like terms, and then we're going to move the 0.75 over by subtracting it and dividing out the 0.20. So at this point we know that he supposedly has 8 quarters. And we need to find out the number of nickels. So I guess we're not quite done because we need to take our 8 quarters and plug it into one of the beginning equations. I'm going to go with the n plus q. So n plus 8 equals 15 coins. We find out that the number of nickels is 15 minus 8, so 7 nickels. So right now we're pretty much thinking we've solved and found the number of nickels and quarters. We've got 7 nickels, 8 quarters. We've used this equation here to tie that together. So the question is, if our answer is correct, it should also fit into the other equation that has the value. So we're going to check that to verify that 7 and 8 are the correct values. So we are taking 7 and 8 again and putting them in here for your number of nickels and quarters. So doing some quick calculations here, 7 nickels is 35 cents, 8 quarters is $2, 235 equals 235, and we are confirmed that our answers are indeed 7 nickels and 8 quarters. And then last but not least, a nice little sentence putting our answers together. Marcos has 7 nickels and 8 quarters. That is the end of this lesson, and we'll do some practice in class.